Good morning, students, and Happy New Year. I'm excited to get you guys back. I hope you had a good restful break, and now we're going to start talking about adding and subtracting rational numbers, okay? This week we're going to discuss word problems. We are actually going to review the rules for adding and subtracting rational numbers, and then we're going to discuss word problems using rational numbers, okay? So we're going to start with just a review of the rules. And we left off the week before Christmas when we were doing addition rules and subtraction rules for integers, okay? Now remember, integers are just the positive and negative whole numbers. That's just a section of rational numbers. All rational numbers include integers, which are whole numbers, fractions, and decimals, okay? So integers is part of rational numbers. So we're going to actually do some of your fractions and decimals this week. Okay, so let's go back over the rules for adding and subtracting integers and all rational numbers, because they are the same, whether you're adding a fraction, a decimal, or a whole number. Okay, so the first one is addition rules. Okay, so let's start with addition rules. And if you can either take notes or just make sure that you are following along, you might want to jot some of this stuff down so you have it. If you have notes, you can use it on the test. We will have a test at the beginning of next week. It's a unit test, and so if you have these rules written down, you may use them for notes on your test. They would be very, very, very helpful. Okay. With that said, let's talk about if you have same signs, which is positive plus a positive or negative plus a negative, that means both of your numbers are the same. So you add and you keep the sign, just like this right here. 4 plus 5 is equal to 9. Well, it's a positive 4 and a positive 5, and those both equal a positive 9. You add them and you keep the sign. Okay? Look at the negative. If you add negative 4 plus negative 5, well, they're both negative, so you add them. Negative 4 plus negative 5 equals negative 9. You keep the sign. Okay? So that's the rules if you have the same sign. Let's look at the rules if you have a different sign. Addition with different signs. Okay, so it says subtract the absolute values and keep the sign of the number with the greater absolute value. Okay, so negative 4 plus 5, well, there's negative and a positive, so we're going to subtract them. So the difference between 4 and 5 is 1. 5 minus 4 is 1. And since 5 is greater, it has the greater absolute value, which means it's further on the number line than 4 is, and it's going positive direction, then our 1 is going to be positive, okay? So remember, absolute value is distance from 0, and if we have a number line and we have 0 here, and we have 1, 2, 3, 4, 5 here, and 1, 2, 3, 4, negative 4 here, 5 is further on the number line than negative 4. So 5 has the greater absolute value. Okay, so that means that the 1 is positive. Now the second one is 4 plus negative 5. Well, negative 5 has a greater absolute value than positive 4. It's further away from 0, so our 1 is negative. Okay? So I want you guys to make sure that you jot that down. You understand addition rules for same sign and addition rules from different signs. And I'm going to erase my number line. I don't want to confuse anybody. Just know absolute value is distance from 0. That will also help you on the test. Distance from 0. Okay. Okay, now let's go to subtraction rules. It says change the subtraction sentence to an addition sentence and then follow the above addition rules. Okay, so we are going to first keep the first number the same, change the subtraction sign to an addition sign, and change the second number to the opposite. If you guys remember, we call this the change rule. Change, because there's two things that you change, okay? The first thing is change the subtraction to an addition, and then the second is change the second number to its opposite. Change the sign of the second number. Okay? It's add. You're adding the opposite of whatever the number is. So if it's a positive 2 here, then you're going to add a negative 2. So let's look at this one really quick. I'm going to erase that so you can see it. All right. Okay, so it shows -7 minus 2. And so when we apply the change rule, we have -7 stays the same, but we add the opposite, so we make this subtraction and addition, and we'll make the +2 a -2. And so now we have -7 plus -2. And so it says refer back to the addition rules. They're both the same sign. So we just add and keep the sign. So -7 plus -2 is going to equal -9. -9. Okay. All right. All right, let's do the second one. It says 6 minus -3. So the 6 stays the same. The minus sign becomes a plus sign, and the -3 becomes positive. So we've done change. Add the opposite. 6 plus 3, so they're the same sign, and they're both positive. So just 6 plus 3 equals 9. Okay, so make sure that you remember how to do subtraction, change, and then you refer back to the rules to adding same signs or different signs. Remember, this works for everything from integers, which is your whole numbers, your fractions, and your decimals. All the same. Okay? Now, these last two little statements are really going to apply to us this week. So I want you guys to look at this really carefully, okay? It says, remember to find the common denominator, which means the same bottom number of a fraction, when adding or subtracting fractions, and then you have to simplify your fractions. And that's something, and I will be honest with you guys, if you were in school, if we were in class like normal, we would be doing most of this without a calculator, but because we're not, you guys will have the bonus, because we cannot monitor who uses a calculator and who doesn't. You guys will get to use a calculator on your fractions. So that's probably going to be helpful for you, because there are some things that you're losing here when you need to be able to simplify, but for what it's worth, for right now, you guys are going to be able to use your calculators to simplify your fractions. Okay, and for decimals, it says remember to line up your decimal points when adding or subtracting decimals. And we will work on that together. And so we will talk about how to line up your decimal points, okay? So this is definitely something that you're going to be talking about this week, and we're going to be doing with our word problems. So take a second look at this really quickly before I move to the next page. And we're going to start on some problems, okay? Make sure you have these down, like I said. If you have this, when we are doing the test, you may use this for your notes. And I would definitely keep these notes if I were you, because that way you'll know what to do. Alrighty. Alright, next page. Okay. So we're going to talk about the first question here. It says, it looks like it's going to be decimals, okay? So we have to apply the rules for adding rational numbers to each word problem. So it says at midnight the temperature is -2.7 degrees Celsius. The wind chill makes the temperature feel 6.9 degrees Celsius colder than the actual temperature. What is the wind chill temperature? All right, so the first thing we do when we have a word problem is that we need to break out cubes. And now we've talked about cubes a little bit, and I'm going to go through what that is again, because cubes is just a way to help you basically take apart and look at a word problem so it's not so overwhelming, okay? So the C stands for circle. So you have C-U-B-E, cube, I guess, means circle. Oops. Got to be able to spell it right. C-I-R-C-L-E, circle. All relevant numbers. And when I say relevant, because sometimes we do have some numbers in a problem that aren't relevant. So that's when you read it the first time through. Sometimes your brain has to decide, no, that was just a time. That's not, even though it's in number form. Or that was just a location of a, so some numbers are not necessarily relevant to the problem. Okay, so circle all relevant numbers. Then the U stands for underline. We're going to underline the question or whatever it's asking. Sometimes it's in a statement form, but it's still, we're underline what does it want? Underline the question. Okay? All right, and then we use C and U a lot. B probably doesn't get used as much, but B stands for box. Box in action words. And that just means the words that state, like if it says colder or hotter, those words are action words. They signify something. If it's colder, it means that it's going down the number line, or if it says hotter, it means it's going up the number line. So those are action words. And so you guys want to box those in. I'm sometimes guilty of just underlining certain things, but that's technically on cubes. You should circle, underline, box. And then E stands for explain your work, which means basically show your work. So you're explaining your answer by showing your work. So you're going to show your work, which basically is cubes. Explain your answer or your work. I'll put explain your answer here. By showing your work. So cubes. All right. So circle, underline, box, explain, and show your work. Okay. Even if you're doing stuff on a calculator, we want you to write certain things out, just so we know that you understand the process that's involved in getting the answer and not just punching stuff in. Sometimes the computation, which is the actual calculator work, and the process setting it up are two different things. All right, so let's start again. We already read number one. We're going to read it again. This time we're reading it for relevant information. And I don't think there was any irrelevant numbers in this, but we'll just make sure. It says at midnight, the temperature was negative 2.7 degrees Celsius. And I think that's pretty relevant, so we're going to circle that. Make sure you circle the negative. The wind chill makes the temperature feel 6.9 degrees colder. And I'm going to box in colder, because colder actually signifies like it's going down. My arrow. Then the actual temperature. What is the wind chill temperature? I think my page moved. Okay, I rebox those in. All right, so that way you can see it a little bit better. Okay, so then we're going to underline the question. What is the wind chill temperature? So if I look back at this and I've dissected this question, I have negative 2 degrees Celsius, and then it says that it's getting 6.9 degrees colder, or it feels like it's 6.9 degrees colder, and colder means that it's less, like goes down the number line. What is the wind chill temperature? So we're looking for, it looks like if we say if it's negative 2.7 already, and it's going further down the number line, we're going to say minus, because that anytime that you are going down the number line, you're going negative direction. So take away 6.9. Okay, and so whatever that feels like is going to be your temperature, and it should be further down the number line than 2.7 or 6.9. So I have a subtraction problem here, so I'm going to go ahead and make that an addition problem. So I'm going to say, actually put red, I'm going to say negative 2.7, change the subtraction to addition, plus, change the sign of the second number, and that is a 6.9, so I'm going to say negative 6.9, because that wasn't negative to begin with, just said it was 6.9 degrees colder. So now I have negative 2.7 plus negative 6.9. I'm going to type that into my calculator. And if I was lining that up, both of my decimals in the tenths place, so they would just line up right on the decimal, just like this. Negative 2.7, and then we'd say plus negative 6.9, and that's how you would write that if I wanted you to write it out. You don't have to, but that's how it would look. Okay, so negative 2.7 plus negative 6.9, and I get negative 9.6. So it is 9.6 degrees Celsius, and that is important that you put that down because this is a word problem and it is degrees Celsius. So negative 9.6 degrees Celsius. That is explaining your answer, is writing your problem out, and then showing your work. Basically, make sure you have your units on there. We'll put work and units. How's that? Okay. All right, so number 2 does not have a word problem. It's just simply a fraction, subtraction. And if we were doing this by hand, we would have to get a common denominator. And so I hope that you guys know that a common denominator of 9 and 6 is 18. So you would basically change your fractions over, and you would have the 18 as your denominators, okay? Keep your signs. Okay, so if I say that 18, because 9 times 2 equals 18 and 6 times 3 equals 18, I know that they're common denominators. I'm going to make this over this way a little bit. Okay, so negative 18. And I always just like to write the denominators first, just so I have everything. So I go over here and I say, well, 4/9, if I know that 9 times 2 equals 18, then 4 times 2 equals 8. And if 6 times 3 equals 18, then 1 times 3 equals 3, okay? So now I have a common denominator, and I know that I have a minus, a negative, so I could actually go, I want to make an addition problem, so I'm going to say negative 8 over 18, change, so plus negative 3 over 18. Look at there. That's some crazy work, right? So negative 8/18 plus negative 3/18. Well, 8 plus 3 is 11. So we say negative 11 over 18. And that does not simplify any further, so that is your answer. Now, if I was just put this in the calculator, I could use my scientific calculator or a fraction calculator on your phone. And you're going to just do negative, use the negative sign, and then put 4/9 plus negative 1/6, and you're going to get negative 11/18. So I didn't have to use a calculator on it because I used common denominator, but I did check my work with a calculator, and that's right. So when you're doing these, if we ask you to show your work, we want you to make sure you at least show that you have this part here. Let me show you this part right here, where you show that you have the change in your sign, where you have add the opposite or change. We want to make sure you have that part, even if you don't show it with the common denominator, because this is what we're trying to really focus on, is the rules for adding and subtracting integers, okay? All right, and the next one I won't do the common denominator. I'll just show you with a calculator how we want you to write it out. On Monday, the value of stock decreased by 3/5 of a point. On Tuesday, the value of the stock decreased by 1 1/3 point. On Wednesday, the value decreased, it increased on Tuesday, sorry. On Wednesday, the value decreased by 5/6 points. What is the change in stock value after all 3 days? So I'm reading this, and I'm like, well, I don't see really anything that would be considered irrelevant math in there. There was no times or anything like that. So I think all the numbers are relevant. So I'm going to go through, circle the relevant numbers. On Monday, the value of the stock decreased 3/5 of the point. So I'm going to circle this. And decreased is my action word, so I'm going to box that in because that tells me that it's negative 3/5 because it's going down. On Tuesday, the value of the stock increased, so I'll box increase in by 1 1/3 points. On Wednesday, the value decreased, box that decreased in by 5/6 of a point. What is the change in the stock value after all 3 days? Underline that. Okay? So the change just means how did it go? It went down, it went up, it went back down. So where are we at now? So all we do is we start with the very first number, and it's 3/5. But we look at the action word that we boxed in front of it, and it's negative because it says decrease by, and decrease is a word that represents a negative. So we're going to put negative 3/5. Okay? Now our next math is increased by 1 1/3. So increased means a positive sign, so plus 1 1/3. Right? And then Wednesday, the value decreased, so that's going to be what sign? Positive or negative? So negative 5 6. Okay? So now it says, what is the change? So basically, we just have to add these together to figure out what our change is. Okay? So we have negative 3/5 plus 1 1/3 minus 5 6. Okay, so I'm going to take my calculator. Now, if I was to look at and get a common denominator with all of these, 5, 3, and 6, my common denominator is going to be 30 because 5 times 6 is 30, 3 times 10 is 30, and 6 times 5 is 30. So if I wanted to change all these over and I didn't have a calculator, Mr. Norton said you have to use your, write it all out, that's what I would do. But we are going to use the calculator. So I put negative 3/5. Make sure you're using a fractions calculator. Do not turn this into a decimal and leave it that way. I want you to leave it a fraction because that's what that's the format of the question. We have to leave it in that. Negative 3/5 plus 1 1/3 minus, or negative, you can say plus negative 5 6, but I'm just going to put minus 5 6, and I get negative 1/10. So we are down 1/10. Okay, which means that if 30 was our denominator, we simplified down by 3 and made it 10. Okay, all right. So we're going to go to the next page. Okay, now it says Maria has a container of oatmeal. She uses a 1/4 cup of the oatmeal container for breakfast and uses 3/8 cup for a cookie recipe. What is the total change in the amount of oatmeal she has? Show your work. Okay, I've read it through once. Now I'm going to go back and I'm going to look for cubes. Okay, circle anything, box the action words, underline the question, blah, blah. Maria has a container of oatmeal. She uses 1/4 cup of oatmeal. So I'm going to say 1/4 cup, and uses, that's an action word, and that's it's negative, right? Because she's using something. She's not putting it into the, she's not putting it in or putting it into the box of oatmeal. She's taking it out. Okay. And she uses 3/8 a cup for cookie recipe. So uses again. So those are both negative terms. What is the total change in the amount of oatmeal she has? So she didn't add oatmeal, right? She lost oatmeal because she was using an oatmeal. Okay. So a lot of you guys are going to just want to add up 3/8 plus 1/4 and be done with it. But actually, it's going to be a negative 1/4 plus a negative 3/8. Okay. So let's do uses is negative 1/4. Okay. And then plus negative 3/8 because she uses 3/8 again. Okay. Let's see if I can make this negative 1/4 a little bit neater. Sorry, it's bugging me. And in my negative sign is in two different places, which is okay because it just references the whole fraction as negative. So now I'm going to say, what is negative 1/4 plus negative 3/8? Okay. And hopefully y'all do get that your common denominator is 8 on this. You would change 1/4 into 2/8, but we'll go ahead and do it on the calculator. So I put a negative 1/4 plus negative 3/8, and I get negative 5/8. So if I could use, we could say negative 5/8. Ooh, hold on just a second. Bad 8. Negative 5/8. Okay. Sorry, I have to write with a stylus, so sometimes it's kind of messy. Okay, so it's negative 5. That's the change in her oatmeal. Is she's lost negative 5/8 of a cup of oatmeal, okay? So cup of oatmeal. Is it important to write that down? Yes, because it is a word problem. If it is not a word problem, you don't have to write out the quantity unless it has it. But if it has a quantity like cups or ounces, you do have to write it in there. If you were rewriting this as a statement, you would say, Maria uses 5/8 cups of oatmeal. That would take care of the negative. Okay, next question. The temperature at noon was 5.6 degrees Fahrenheit. During the afternoon, the temperature dropped 2.8 degrees Fahrenheit, then dropped another 2.2 degrees Fahrenheit in the evening. Find the new temperature. All right, so I don't see anything that was really irrelevant math, so all the numbers seem to be relevant to the problem. So we'll go back through. The temperature at noon was 5.6 degrees Fahrenheit, so I'm going to circle that. And it doesn't look like there's any action words ahead of it, so just 5.6. It's a positive. During the afternoon, the temperature dropped. Dropped is an action word because it signifies the temperature went down. So it would be like a negative 2.8 degrees Fahrenheit. And then it dropped, which is another action word again, another 2.2 degrees Fahrenheit in the evening. Find the new temperature. Okay, even though this is a statement and not a question, it still needs to be underlined because it tells us what we're looking for. All right, so we go back and we have 5.6. Well, it's a positive because there's no negative action word in front of it, and it doesn't have a negative sign, so we just write 5.6. Okay, and then it says it dropped 2.8, so I'm going to say plus. You can either write minus 2.8 or you can just write plus a negative 2.8. It's whatever you want to do. I could have just said minus 2.8. Okay. And then it dropped again, so I could either write minus 2.2 or just put plus negative 2.2. And then find the new temperature. Okay, so from here, we are just going to put this in the calculator. Okay, so we have 5.6 plus negative 2.8 plus negative 2.2. I get a 0.6. So the temperature is less than 1 degree Fahrenheit, but it's 0.6 degrees. So I'm going to write 0.6 degrees Fahrenheit. And that is me explaining, showing my work. Okay, question number 6 says, Austin volunteered to work 7.5 hours at a weekend fundraiser. On Saturday, he worked for 2 2/3 hours. How many hours does he have to work on Sunday? Okay. All right, so I don't see any irrelevant math in here. So we're going to go through and we're going to read it again and pull out what we need with cubes. Austin volunteered to work 7.5 hours. Okay, so we're going to circle 7.5 at a weekend fundraiser. On Saturday, he worked for 2 2/3 hours. So I'm going to circle 2 2/3 hours, okay? And then the question says, how many hours does he have left to work on Sunday? So this one is kind of a reverse thinking, because if I write Saturday plus Sunday is going to equal the total amount of time. Well, it actually gave me the total amount of time, and then it gave me Saturday, so I have to think backwards. So I'm going to say if my total was 7.5 hours, and I have already worked, so if I've already worked for 2 2/3 hours, I'm going to write minus 2 2/3. Now, this one is kind of tricky because it doesn't really have any of those action words in it that you would stand out and say, I can box this because I know this is a negative word. You have to use your common sense on this and show that you know, if you have a total of 7.5 hours and you work 2 2/3 of those, what are you going to have left to work? Okay, so it's subtraction. Now I could use my change on this, or I can just subtract, and I'm just going to subtract on this one. So I'm going to say 7.5 minus 2 2/3, and I get 4 5/6 hours. HRS. So Austin has 4 5/6 hours to work on Sunday. Okay. All right. I think we are going to end there. I gave you guys 6 examples, and I think that's good enough. If you are going to do the first couple of assignments, will be just the integers, and you're going to have to remember the rules. And then I believe your third assignment has more to do with fractions in their word problems. Okay, so you will have fractions and decimals on your quizzes, and you will have fractions and decimals on your exam. So like I said, make sure that you understand the rules for adding rational numbers, and you can use your notes if you would like. Have a great day.